This is Mr. Martin. These are the video notes for Geometry Honors Section 6.3. In this video we're going to be talking about basic facts related to parallel lines. So let's start out with a definition. If a line and a plane do not intersect, then they are parallel, just like two parallel lines. So you can see line AB is kind of hovering over plane M. And really I can spin AB anywhere that we would want, and it would still remain parallel. As long as I don't tip one of the ends up or down, it would still remain parallel. And as always, if you have questions about these or you need some more explanation, make sure that you write down your questions on the side and ask me next time you see me in class. Another definition, if two planes do not intersect, then they are parallel, so we can also have parallel planes. When you're thinking about parallel planes, maybe you want to think about the floor and the ceiling in a room, or maybe opposite walls. Those would be parallel planes. And a note here, there's going to be two possible relationships between two lines on different planes. And this can be a little bit confusing, so again, make sure you ask me if you have questions and I can explain it to you in class. They can be skew. The two lines can be skew. They're two non-intersecting lines that are non-parallel. So normally when we talk about two lines that don't intersect, we're talking about parallel lines. But now, if we take those two lines and we put them on different planes, so you can see we have CB on this upper plane, actually AB on the upper plane and CD on the lower plane, you can see that they're not parallel, but since CD is underneath AB, they'll never intersect. Okay, we say that they are two non-coplanar lines, so I can use the word skew, or I could say they are two non-coplanar lines, and this means the same thing. So make sure you understand that we can use those terms interchangeably. Or they can be parallel, in which case the two lines determine their own plane. So I'm actually going to use this picture here. If I've got that AB is parallel to CD, we can see that AB is on plane M and CD is on plane N. And since these are parallel and we know that two parallel lines can determine their own plane, I know that there's also a plane S, that is formed by or determined by AB and CD together. Okay, so really this is a picture of this as well. And then we can kind of talk about the converse of that, same picture here. If a plane intersects two parallel planes, then the lines of intersection are parallel. Okay, so for this we might be given, or if we know that plane M is parallel to plane N, then we can conclude that AB is parallel to CD. Okay, if a plane intersects two parallel planes, so we've got S intersecting plane M and N, which we either know or can prove are parallel, then we know the lines of intersection are parallel. So this is going to be important for us when we're doing proof, so make sure you understand this. As always, I know I sound like a broken record, but if you have questions, write them down and make sure you ask me. So some properties relating parallel lines and planes. And again, if some of these aren't clear to you, make sure you ask me. If two planes are perpendicular to the same line, then they are parallel to each other. Number two, if a line is perpendicular to one of two parallel planes, then it is perpendicular to the other plane. If two planes are parallel to a third plane, then they are parallel to each other. So this would be kind of like our transitive property of parallel planes. And you may want to try and sketch some images for these. I know in the three-dimensional pictures it gets a little tricky, but see what you can do. And then if you want to show me in class, take a look at those. Number four, if two lines are perpendicular to the same plane, then they are parallel to each other. And the last property, if a plane is perpendicular to one of two parallel lines, it is perpendicular to the other. Again, so you may want to draw some pictures, see what you can do on those, and then ask me in class if you have questions. So let's take a look at an example here. We're given that planes M and N are parallel, and we're given that AB lies in M and CD lies in N, and we know that AC and BD are parallel, and we want to prove that ray AD bisects BC. So one of the spots where students typically get stuck is that really what you need to do is, in order to work with this figure in the middle, ABDC, we first need to know that it's a plane. And we have a couple different ways to determine a plane. Actually, we have 4 ways, but you need to pick the way that's appropriate for the problem and for what's given in our problem. And we know that one of our ways to determine a plane is 2 parallel lines. So I've got that AC, the left side, and BD, the right side, are parallel. So this determines a plane. Okay, and then we'll use that in our proof. Once we determine that this is a plane in the middle, then we can treat that as a quadrilateral. And that's going to be important. And again, thinking ahead, if we're trying to prove that AD bisects BC, we've got a quadrilateral here, and we know that if our quadrilateral is a rhombus, then this would, and this is a diagonal, it would bisect the angles. Otherwise, we're going to have to prove some triangles congruent and use CP/CTC. But thinking ahead, let's see if we can get this either to be a rhombus or even maybe a square. And then we'll be able to show that this ray bisects that angle. So let's put the given information in here. We have M is parallel to N, and we've got that AB lies in M, and CD lies in N, and we've got that AC is parallel to BD. So these are all given. Given for 1, given for 2, given for 3. And we already decided that since AC is parallel to BD, that ABDC is a plane, and our reason here is 2 parallel lines determine a plane. Alright, so I've got that AC and BD are parallel, and we also have that this plane that we just named intersects 2 parallel planes, and we know that the intersection of a plane with 2 parallel planes, these have to be parallel as well. So I've got that AB is parallel to CD if a plane intersects 2 parallel planes, then the lines of intersection are parallel. Let's fix this word over here. Alright, so now we have both pair of opposite sides parallel, so we know that it's going to be a parallelogram. So now I've got that ABDC is a parallelogram if both pair of opposite sides of a quadrilateral are parallel, then it's a parallelogram. Okay, so at this point, we can prove what we want to prove. I misspoke before, I read the problem wrong. We're trying to prove that AD bisects BC, and we can see that these are the diagonals of a parallelogram, and we know that one of the properties of a parallelogram is that the diagonals bisect each other. So once we know it's a parallelogram, we can go ahead and state our conclusion. So step 7, segment AD bisects segment BC, and our reason is diagonals of a parallelogram bisect each other. So you can see how knowing those properties of the different parallelograms are going to be important. This saves you a lot of time and effort in order to prove this. So as always, if you have questions, make sure you ask me in class, and we'll see you next time.